Welcome to the Aerospace Ambition Podcast. I'm Marius, an engineer passionate about sustainable aviation and AI, and your host today. First up, a heartfelt shout out to Kieran, who won't be with us today as he's deeply immersed in the final stages of his own PhD research. And I think I can speak for all listeners when I say how much I am or we are looking forward to interviewing him about his own research. But rest assured, I will try everything to have him as a co host for more episodes in the future, particularly on topics related to climate and contrail science. Today, however, we shift our focus to the regulation of sustainable aviation, covering significant areas like the carbon offsetting and reduction scheme for international aviation, the European Union emissions trading system, and the consideration of non-CO2 impacts within these frameworks. I'm thrilled to have the ideal guest joining us to dive into this discussion, and I look forward to an enlightening conversation. Today, I'm joined by Kay Köhler. He's a senior technical officer at the Aviation Unit at the German Environment Agency, or UBA. Kay has a master in public administration and a master in aerospace engineering. He was in charge of emission protection, including noise and air pollution control for stationary installations at the city of Berlin for about 10 years. Since 2013, he has worked at UBA with a focus on the EU ETS and CORSIA and non-CO2 effects of aviation. Furthermore, he's a member of multiple European working groups on aviation. With that, welcome Kay to the show.
Thank you very much, Marius. And thank you very much for the kind introduction and of course for the invitation to your podcast. And I would like to mention before we start the discussion, really like to congratulate you to that very ambitious podcast. And please send my greetings to Kevin if you talk to him.
Well, you've just done that, and of course, the compliments are well appreciated. And ambition is not as a coincidence part of the name here. And with that, I'm also looking forward to discussing this with you, and especially, so I said UBA, which is basically the German kind of abbreviation of the German Environment Agency. But of course, to set the scene, could you tell our listeners what is the UBA? What is this agency? What are its responsibilities and activities?
Well, US, Germany's main environmental protection agency, and we concern ourselves with an extremely broad spectrum of issues, ranging from like approvals for pesticides over climate protection, and that's the area where I work in, to well, I don't know Z, but at least W, to waste avoidance. Uber has almost 2,000 employees, I think, and our work centers around gathering data concerning the state of the environment, investigating the relevant interrelationships, and making projections, and then, based on these findings, providing federal bodies such as the Ministry of Climate Protection or European bodies such as the European Commission with policy advice. But of course, we also provide the general public with information. And that's a very important part of our work. But apart from these activities, we implement environmental law by making sure that is applied in areas such as emissions trading. That's part of my job, and many others. And our overarching mission, I think, is the early detection of environmental risk and threats, so that we can assess them and find viable solutions for them in a really timely manner. And we do this by conducting research in our own lab, and of course by outsourcing research to scientific institutions in Germany, and even abroad.
All right. You have two master degrees, and one is rather technical, and the other one is aerospace engineering, and the other one is public administration. So, how can you balance those two disciplines within your daily job?
Well, I think it's perfect to have both masters. In our unit, we deal with the emissions trading directive, and in Germany, it's the Greenhouse Gas Emissions Trading Act, and with aviation. So it's good to know regarding the emissions trading directive. We have to check or approve monitoring plans. We have to check emissions reports, and we have to sanction procedures. and this for aviation. And so I can really combine both masters. So I have the public administration is kind of a legal background, and the aerospace engineering is a technical background. So I can really good combine both.
Brilliant. So you've joined in 2013, and this includes a couple of legislative periods. And I have to ask this question because we never had someone as close to politics as you are on the show yet. And so I'm really curious how this works. I mean, every 4 years you have someone appointed, a new minister, right? That comes from well, that is elected essentially. And I'm just trying to figure out, like, the first couple of months after such an appointment, right? Do things change, and how do they change?
I think they do not change dramatically. Our unit reports to unit in the ministry, and this unit sometimes works in the ministry for the environment, or sometimes in the ministry for climate protection. But they're always the same persons that we talk to in the ministry, and of course in the European Commission. So the persons we talk to, or we change ideas with, are still the same. So I think it's not a dramatically change that we are confronted with after the elections.
What is your unique perspective in this whole ecosystem of stakeholders? Of course, I'm looking a little bit at, for example, non-CO2 effects in aviation, but just generally speaking, you've seen all the guests that were on this show, and it's a quite diverse background, right? They all are different stakeholders with different agendas, etc. So, how would you describe the unique perspective that your agency brings to this ecosystem?
Yeah, I think what we really can do, we are a competent authority. Yeah, so we are not researchers ourselves too much. In our unit, we are not legal experts too much, but we are part of both. So, and maybe what's worth mentioning to say, in our unit, we have someone who formerly worked for an airline. We have someone with a pilot license. We have someone who worked for a verifier. So, and we have at least three aerospace engineers. So we have really knowledge from different parts of the whole process chain, yeah, from verification to monitoring of data to sitting in a cockpit. And so, but we have really insight into both sides. So we can do research, or we can tender research, and we do administer the EU ETS and CORSIA. So we have insight into both sides, and we know how important it is to combine both sides. I think it's really important sometimes for the people we work with. That researchers say, okay, here we do all the research, but we do not know what it will change. And then we have all the legal experts who say, okay, we know the law, but we do not know the technology or the science behind that. And that's what is really combined within our unit and within Uber. And so we have really, I would say, a good insight into both sides of the medal.
So to summarize, it's basically like a process where you have input, process, output, and the input, or let's say the process would be in the German parliament, right? The elected members, they vote, and this is how decisions are made. For example, on a national level, and you would provide input for those decisions, but when they are decided, you would also implement the law.
Principally, yes. I think what's important to mention is that it's European law. So it's the European Emissions Trading Directive, and this directive has to be translated into German law. But so the within the member states of the European Union, the law is pretty much the same, because the basis is the European Emissions Trading Directive. So of course we do advise our ministry, but we do advise the European Commission and the European Parliament as well, and the decisions for the law are made within the European Parliament.
Do you have maybe a tangible example of a challenge when you have to translate a European law to the German law?
This is what has just been done a few months ago, and the process is still not finished. The amended emissions trading directive has been published, I think, last summer and has entered into force on January 1st, 2024. But the European Emissions Trading Directive cannot be applied directly in Germany. It needs to be translated into German law, and so the Emissions Trading Directive needs to be translated into the German Greenhouse Gas Emissions Trading Act. And this is it's hard work. It's not just copy and paste European law, but it's really to combine it with existing German law and with things that only apply in Germany, and other member states do it in a different way. So it's not that at the end all the national laws look pretty much the same. They look really different, but they have to aim at the same goals, which are laid down in the European Emissions Trading Directive.
If I make a trip from Munich to Hamburg, I take the train. So the dominating share of flights is international, right? And that means that you have multiple countries involved in that process, right? In a flight from A to B.
Mhm.
So how do you, this is a very high level question, but how do you regulate aviation in terms of emissions?
It really depends on whether we talk about a global system or European system. Within Europe, it's the European Parliament who makes the decisions, or who makes the law. And so, of course, there are 27 member states in the EU, and then we have some other member states like Norway, Iceland, Liechtenstein, who belong to the European Economic Area and who do also apply the Emissions Trading Directive. So you have many member states and the interests of many member states that need to be brought together. The member states discuss, the people in the parliament discuss in the European Parliament. Then we try to advise the parliament. But I think in Europe, it's still, although there are so many member states, I think in Europe it's still much easier to find a solution than on global level, on ICAO. So I think the environmental goals for most member states are quite the same. But then imagine you're on the global level and you have 200 ICAO member states, and they have really different political and economic systems, and some have really large airlines, others have not, and so. And then I think it's really hard work, much harder than within Europe, to find a way, or globally, or a legal text globally. So I think the CORSIA negotiations are still much harder than the European negotiations.
How do we get from a scientific discovery to legislation? Because eventually airlines are companies, and for them to take an action, we need legislation. What is the process from, I mean, we heard researchers in previous episodes, they have discoveries all the time. So what is the high level process from there to the actual implementation?
For non-CO2 effects of aviation, this was a major topic in our unit at UBA for, I would say, for the last 10 years. And here we went the whole process from having scientific knowledge to having a legal text, and together with many others, we went the whole way from really seeing the need of finally integrating the non-CO2 effects into the UTS to having it then finally integrated. And it's fair to mention that we're not the first ones who discovered, of course, non-CO2 effects, or we were not the first who had the idea to integrate the non-CO2 effects into the ETS. But as a first attempt has failed 15 years ago or so, we wanted to make sure that this time it will be really successful. And then when we talk about non-CO2 effects, maybe it's worth mentioning that one should be aware that the main impacts result from contrails and NOx emissions. But however, the focus is very often on contrails, and I'm not sure why, but maybe because you can simply see them, or maybe because they are might easier to be avoided. But to come back to a question, what did we do for the integration into the UTS? So approximately 10 years ago, we asked ourselves the question, what is necessary to include the aviation non-CO2 effects into the ETS? That were questions like how to monitor the data that are relevant, or how to calculate the climate impact. And then we tendered a research project that has been contracted out to the German Aerospace Center, and that dealt with all the basic questions. And based on the promising results of that project, we launched a follow-up project where the ideas for monitoring and the calculation of data of the first project were tested in practice. And once again, with DLR and the airline European Air Transport Leipzig, which is a big German cargo airline. And of course, then we had results. But according to the German saying, "Do good and talk about it," we shared, and that was a really important part of the way or of the work. We shared the results of the project permanently and really often with our climate ministry, with the European Commission, with the European Parliament, with NGOs, with the industry, etc., etc. And that during the whole process of the amendment of the Emissions Trading Directive, which I think started in 2021 and has been finished in summer 2023. And it has been finished with the integration of the non-CO2 effects of aviation into the EU ETS. And I think this had never happened without the research and we started, and the advice we gave to all the bodies that were involved.
I didn't know about this first attempt 15 years ago. I heard about, the 1999 IPCC report, which already mentioned contrails. Is there a learning that you derived from this, let's say, air quotes, failed attempt? Like, is there anything that there was a clear learning that you could apply then to the follow-up try?
Yeah, I think we what we've learned is that we need more research, and because during the first attempt to include the non-CO2 effects of aviation into the UTS, it was thought about having a just as constant factor on the emitted CO2, and this approach was taken into account then. And fortunately, this approach has not been chosen because the relationship between CO2 emissions and non-CO2 effects is anything else than constant. Instead, it's highly nonlinear and depends on many factors. And since a constant factor would have set the focus only on the reduction of CO2 emissions, and since there might be a trade-off between CO2 and non-CO2 effect, a constant factor could have led to increasing total climate impact of aviation. And this would be the worst thing that could have happened. Yeah, to implement something that should reduce the climate impact of aviation into the EUTS, and afterwards it could have led to higher climate impact. And so that's why we thought, okay, we really need a really a flight by flight assessment. So we cannot simply multiply these emissions by with a factor. We need really a flight by flight assessment of the CO2 emissions and of the non-CO2 effects. And this is much more work than just to monitor the CO2. And that's why we did all the research, and it was really a long and hard way. Yeah, it took us I don't know, 7 or 8 years. It was really much research, much advice, but I think at the end it's a really good approach that we now have in the European Emissions Trading Directive.
Could you maybe summarize from your point of view where do we stand right now? What was this exact result of these 7 8 years of preparation?
I think the exact result was that it's technically and from standpoint of atmospheric science, it's feasible to include the non-CO2 effects of aviation into the UTS. The whole process is harder than to monitor and report the CO2 emissions. It's quite easy to do that. It's harder to do that for non-CO2 effects, but the result was that it was technically feasible.
So we've just learned the important impact that you have made and the Uber have made in coming to the conclusion that non-CO2 effects can be included in the EU ETS. What we need to take into this consideration is, of course, also CORSIA.
Yeah, CORSIA stands for Carbon Offsetting and Reduction Scheme for International Aviation of the ICAO, which is the International Civil Aviation Organization, and CORSIA applies to international civil flights globally. And I think it's worth mentioning that CORSIA is the first global measure for climate protection of a specific sector. So no other sector worldwide has its own measure for climate protection. And the current overall goal of CORSIA is to keep the CO2 emissions of international aviation on the 2020 levels. And this is the so-called CORSIA baseline. But in the future, we hope or we see the need that based on CORSIA, the ambition for reducing the climate impact of aviation should be further increased, of course.
You've basically mentioned the baseline of CORSIA and also that the positive climate impact in the future may even be increased. Now it's part of the name, right? Carbon offsetting and reduction scheme. I think it's also worth noting what is this offsetting actually? Like what are actually the measures that are coming out of this scheme?
Yeah, I think this is one of the main differences to the UTS. CORSIA, in contrast to the UTS, that is a cap and trade system. CORSIA is a baseline credit system, and in the baseline credit system, airlines are not limited at all in emitting CO2. Yeah, what they are obliged to do is to offset all emissions over a specific baseline, which I mentioned already, with so-called offsets. And offsets are, yeah, another word for offsets could be certificates. And these offsets can be generated principally unlimited by reducing CO2 emissions somewhere else. So basically, I would say that CORSIA relies on the emission reductions somewhere else. So somewhere else in the world, the emissions need to be reduced so that airlines can buy offsets and can hand it over to the authorities. However, I would like to point out that the projects for reducing emissions somewhere else can come along with other benefits for the people who participate in those projects. And so, besides the pure emission reduction, the projects can, for example, improve the life quality of the participants. And I think this is really an advantage of the offsets. And of course, that's a really important point is we have the principle 1 ton is 1 ton. So I think it's really important to monitor that the projects or that the one who sells you an offset and says, okay, one ton of CO2 has been saved here within the project, that this has really happened, because otherwise it's just giving money to somebody else and without any positive climate impact, let's say.
To further understand how CORSIA works, I'd like to understand, or maybe can we take an example flight from like A to B to understand where it applies?
A domestic flight, for example, in Germany is always a flight that is assigned to UTS because it's not international, yeah, and it's within Europe, so it's assigned to the UTS. Then we have, for example, a flight from the US to Canada, and this is an international flight assigned to CORSIA because in North America there is no other system than CORSIA. But I think that's quite easy, two quite easy examples. But then we have some two other kind of flights who are, I think, more complex. Let's think about a flight from Paris to Rome, or a flight from Amsterdam to New York. I think it's important to know that within the EU, CORSIA is implemented via the UTS. That means the flight I mentioned from Paris to Rome only falls under the UTS, as the UTS is a more ambitious system. Lufthansa, for example, does not have to compensate the flight twice, only under the UTS. But then we have the flight from Amsterdam to New York, and this flight currently only falls under CORSIA because the UTS is currently limited to inter-European flights. Yeah, the original scope of the UTS was flights within the EU and to and from the EU, but to to support the CORSIA negotiations, the UTS was limited to inter-European flights, and so currently this flight is only regulated by CORSIA, but in the future it might be regulated once again by the UTS.
I'm wondering, are there any loopholes in there? For example, if I take the car, right, from Germany and I go to France, then I know I can take some gas in Luxembourg. And I'm wondering if there's any things like that with regards to CORSIA as well. For example, I don't know, then doing a small stop somewhere.
Principally, this might happen. For example, if you we have often the fear of let's say European airlines that international flights are shifted to let's say Ankara or Dubai or so that they avoid European airspace because if you have flights within Europe they fall under UTS, but if have a stop or a flight from let's say Ankara or Dubai to Frankfurt to New York, it only falls under CORSIA, not any longer under the UTS. This would mean that the more ambitious system is not taken into account. This was not the case when we had the full scope of the UTS. So both flights would have fallen under the UTS, and which caused more climate protection. But yeah, it's currently it's not the case.
You've just pointed out how, you know, a certain flight connection would go for either CORSIA or the ETS, or the more ambitious system applies if you know both apply. Is it that simple, or is it actually bringing those two systems together? Is there still work in progress? Is it more complex than that?
It's really complex. As I mentioned, we had the full scope of the UTS in the past, and then the European Parliament says, okay, to support CORSIA, we use the UTS, but several times since then, European Parliament, okay, if CORSIA is not ambitious enough, the full scope will once again be applied. So if the CORSIA baseline would be too high, for example, yeah, then we will get back to the full scope, which means flights from Europe to all over the world would fall under the UTS. So I think it's a really hard political process.
Looking at the timeline for the MRV, could you maybe briefly highlight what are the milestones in this decade for the MRV and the inclusion of non-CO2 effects, the expected ones, like everything as far as we know?
I've mentioned, and I think it's really good news that the aviation non-CO2 effects are now included in the UTS, and that airlines have to monitor and verify, and that's why it's called MRV. MRV stands for Monitor, Report, and Verify the non-CO2 effects of all flights within the EU, within the UTS, I have to say, from 25 onwards. And with all flights here, I really mean all flights within the EU to and from the EU, which means that approximately one third or one fourth of global flights fall under the system. And then until the end of 2027, the European Commission shall submit a report with a legislative proposal to mitigate non-CO2 aviation effects by expanding the scope of the UTS to include non-CO2 aviation effects, which means a surrender obligation, or in other words, that then the airlines have to pay for their whole climate impact. However, and this is for me, it's very important to say that the intention of that surrender obligation is not to generate a lot of new revenues, but to create incentives that airlines make really use of mitigation options. Yeah. And I'm often asked why there's a 3-year period with only MRV, and well, I think this is not unusual. When aviation has been included in the UTS with CO2, there has also been a 2-year MRV period, and this period was used to create knowledge and to overcome initial difficulties at the airlines, but and at the verifiers and the competent authorities as well. Since non-CO2 effects are more complex, as I mentioned, a 3-year period seems appropriate to me. And regarding CORSIA, there's so far no proposal how to include non-CO2 effects into the system, but of course, ICAO deals with the topic. There's movement on international or on global level as well.
So the goal is rather to create incentives for operators to, be climate optimal, and this leads to, I mean, incentive is associated to dollars or euro values, right? Now everyone highlights or speaks about the uncertainties. How do you get to a conclusion to say, well, there are uncertainties inherently in this complex kind of a problem, but this is where we draw the line. So this is actually the kind of price tag that we're going to attach to this incentive. How do you get to that decision?
The uncertainties, this is something we really hear very often. I would say more or less daily. I'm happy that you asked this question because I would like to. I'm happy to make a statement on that. First of all, I would like to start. Although we always talk about uncertainties, but first of all, I would like to start with what we know. Yeah, we do know that there are non-CO2 effects of aviation, and we do know that their warming impact is very probably much higher than the climate impact of aviation CO2 emissions. Probably the non-CO2 effects have a climate impact that's probably twice as much as the CO2 emissions. And we do know that the share of the climate impact of aviation will very probably rise in the future because the growth in aviation is very high. And you mentioned this, there are uncertainties. And although much progress has been made in the last years, the uncertainties for non-CO2 effects are still large, yeah, and they will probably never be zero. Maybe they will not be close to zero because depend on the weather, and we all know how difficult it is to predict the weather. But what should then be the solution? Yeah, should we simply lean back and hope for wonder, yeah, or should we think, okay, we are already old enough that climate impact or climate change will not affect us too much in our personal future? So I think the answer can only be no, and I think our whole life consists of uncertainties. And you probably have heard of the precautionary principle. That means that in the event of incomplete or uncertain knowledge of the nature, extent, or probability and causality of environmental damage and dangers, one acts in a precautionary manner to prevent such environmental damage from the outset. And another very important principle is the polluter pays principle, which in my is really self-explanatory. I mentioned we have to find a way to deal with the uncertainties, and of course, even after we had 2 years of MRV, we will not be able to calculate the climate impact without any uncertainty. So we really need a strategy how to deal with them. And here, one approach could be that, for example, that we say, okay, the airline reported 10 tons of CO2 equivalents for specific flight, but regarding to uncertainties, it might vary between 5 tons and 15 tons. So, but for 90%, for example, we are sure that the impact is at least 6 tons. So 6 allowances have to be surrendered by the airline. So this is a way, there's a possible way forward in order how to deal with it. But I think what I would really like to point out, we do know non-CO2 effects have a warming climate impact, and that's why we have to reduce them.
This leads to a more precise question. So, our previous guest is a NASA engineer, Richard Moore, conducting wake experiments. And he asked a very hands on or clear question: when will there be a price tag on contrails?
Hopefully, I think it will be the case from the year 2028 onwards, because in the emissions trading directive said that the European Commission shall submit a report until the end of 2027 with a legislative proposal to mitigate non-CO2 aviation effects by expanding the scope of the UTS to include non-CO2 aviation effects. So, which means a surrender obligation. So this is what we do for the research to supplement the policymakers with more information, with more research, so that they're really convinced that from 2028 onwards, airlines have to pay for the warming contrails they produce.
You spoke a couple of minutes ago about the certainty and said that we shouldn't stop acting just because there is some uncertainty, but we should think about how we actually act and deal with that uncertainty. And on one of the recent episodes, we had Alejandro Block on from IATA, and he was raising concerns or raising caution with regards to mitigation, and essentially he put out like two points, meaning that the way that we are quantifying, the impact, the climate forcing of contrails as of today is that we take reanalysis weather data, so weather data from the past, and then we feed them through the models that we have, and that there are papers out there who suggest that when you compare those results from those models with in situ measurements, that there is still a huge gap. And so he concluded that this can't be done accurately enough. And he also said that there is a great variability of the climate impact of the radiative forcing from contrails. And so if we put a number on it, that is what he said, if we put a number on it, how meaningful will the number actually be that we are reporting, and what should we do with that number? How would you respond to that?
At the end, we need a surrender obligation or payment. And already made I already mentioned an idea with a 60%, for example, that only a number of the reported emissions fall under a surrender obligation. But in the coming years, in the 3 coming years, I think what really needs to be done with we MRV system is we need knowledge and we need experience on the reporting and monitoring of the data in order to 2 years be really sure that the monitoring and the reporting really works. Because monitoring and reporting is a really important part of, because it's the basis for the surrender obligation. So the MRV system principally should make sure that we can really rely on the monitoring and reporting processes, so that we are pretty sure that what we have monitored in order to calculate non-CO2 effects is the exact data. And then, of course, I think if the airlines would think, okay, we hand over the data that we have monitored to scientists, I think there would be a huge amount of data that can be used to further improve calculation models and weather prediction models to really help our understanding and meteorological and atmospheric science. So I think this is a second very important point that the MRV system where the MRV system could help. And then you mentioned, would it make more sense to, after the flight, to recalculate the data? I think it's good for comparison, but I think it's not the best idea. I think I would say it's a bad idea for the UTS or for surrender obligation under the UTS. Imagine you have an operator who says, okay, my initial flight planning would be this route, but then I here have the weather forecast data, and with the weather forecast data and the climate model, the climate optimized route would be another one. So the operator would do a rerouting in having really a good will to do some climate mitigation. And then after the flight, it is found out that this route was not the best one, but it might be the worst one. And then the operator would have to, or the airline would have to pay much more for allowances with the recalculated data than with the weather forecast data. And so he would be penalized for goodwill, and I think this should not happen under the UTS. Yeah, I think this can be done for scientific research, but not under the UTS.
And what is the alternative?
The alternative is that you use weather forecast data. Yeah, and the better the weather forecast data is, of course, the better the decisions are that the airlines can make. If we would have really precise weather forecast data, and if with the weather forecast data you could calculate the climate optimized route and you fly the climate optimized route, then this would be the best solution.
Okay. Since you mentioned better weather forecasts, I'm squeezing in one of our traditions here, and that is passing on the question to the next guest. So the subsequent guest will be Peter de Bock. Is there any question that comes to your mind? Could be anything super deep, intellectual, or fun that I could ask him?
Yeah, it's a question I asked myself for a really long time, because I've heard that only 7 or 9 aircraft within Europe and 20 aircraft in the United States are equipped with humidity sensors. I really don't know why it is so hard to have humidity sensors on aircraft.
Oh, me too. I'm glad that you brought up that question because it's definitely going to be asked in the next couple of episodes, and then specifically to Peter as well. Is there anything else, Kai, that you'd like to share with the audience?
I think what's important to us is that aviation is climate friendly. This is important to us, and not and nothing else. So with that, I would like to give back to Marius, and would like to thank you for listening, and Marius, and thank you for the very interesting questions, and once again for the very ambitious podcast.
Thanks so much, Kai, for taking part, and speak soon.
Bye.
Bye bye.